Nice.
Yeah, it's good.
All right, so this is Anne's prosthesis, and we just took the foot shell off. This is called the foot shell. This is called the foot. Very creative, I know. This is a Spectra sock that goes over it, and the Spectra sock is made out of a material called Spectra. It decreases the friction that occurs between the carbon and the rubber. We like to call it the coefficient of friction. You guys might be learning about that. So her foot is laid out with several thousands of layers of carbon, actually. If you look really closely at it, you'll see all these teeny lines that lay up, and the amount of layers and the direction of the carbon is selected based on Anne's activity and her weight. So each patient has puts a different amount of force through the foot, so we have to allow the foot to flex more based on how much energy they're going to put into it. So you take a look at that when you pass this around. This is the toe and the heel. The heel is bolted on, so the heel can be switched out separately if it wears down or breaks or something like that. Nice. There's kind of a dual spring design on this, so it's when you put this on the floor and you try to bend it or you hold it in your hand, it's not going to move very much unless you're, the strongest man in the world probably. But you can see it move a little bit. But you have to appreciate that somebody's whole body weight and all their energy is going through, and they can get a lot more motion out of it than I can with my hand. So it's a split heel design. So when you kind of do this to the toes, the idea is that when Anne steps on the inside of her foot or the outside of her foot, just like someone that has their foot, it can accommodate the ground a little bit better. They call it ground compliance. This little gray ball offers torsion as well as vertical shock or shock attenuation to try to lessen the forces going through her leg. These are all little things that we're trying to do to make a prosthesis act like our real anatomy acts, and I hate to say it, but we're far from the real thing. These get us kind of close, but our real legs are pretty amazing. Everything they do, from the little bit of torsion and shock absorbing that we have all throughout our legs, all of our anatomy is quite impressive. So then these are components that allow us to adjust height as well as angles. So we can do flexion extension. This is in the coronal plane. This is the sagittal plane, and then this one here is going to be the coronal plane or the frontal plane. So that's inversion, eversion, or abduction, adduction. And then in the transverse plane, then this is internal and external rotation. So that's this little tube clamp adapter. We loosen that, and we can change the angle of her toes going in or out, make her pigeon-toed or not. And then there's the socket. Anne will probably say this is probably the most important part of the whole prosthesis, because if this doesn't feel good, then it doesn't matter. You could have the best, most high-functioning, high-tech foot on the market.
Expensive, yeah.
Yeah, and if it hurts to wear, then you're just not going to wear it. So this is where a lot of it happens. This is the socket, and it's the interface of a prosthesis to somebody's body. So it's really important to try to match their anatomy and accommodate. Our bodies are dynamic and these are static. So it's a challenge to try to make a static device match something that moves dynamically as well as through fluid. Our bodies are, our hands are different in the morning than they are at night, and the same is true for everything else. So hopefully that's a good summary. I know it was quick, but I'm happy to answer any questions.
Can we take that liner off? Or that,
yeah,
that little, just for a sec so they can see.
This is, by the way, this is called a diagnostic socket or a test socket.
Take those.
Yeah. So it's made out of a material called Surlyn, which is a plastic that is easy to manipulate. So it's I can heat it and I can mold it. It's a thermoplastic, so it can react to heat and change, versus a thermoset, which is what carbon is. When you use a thermoset, you're creating an exothermic reaction where the chemicals cure, and then once they're cured, I can't change that shape again. With thermoplastics, I can. So a test socket or a diagnostic socket, we use thermoplastics so we can make adjustments, because right now Anne's just in the process of getting a new prosthesis, and we're trying to get the fit right. So we use this because we can trim it easily, we can heat it, stretch it. I have some pads in there where we added to tighten up certain areas. And then all of it's just epoxied onto a plate, and then I wrapped fiberglass around it. So this is all very temporary, so we can get the fit, the alignment, the height, all of that set before we actually transfer it to a finished product.
Thank you.